Okay, today we're going to look at some problems from section 3.4 using the quadratic formula. Now recall, as long as we're in standard form, which means that we have ax squared plus bx plus c equals 0, then we can use the quadratic formula to solve for x, where x would equal negative b plus or minus the square root of b squared minus 4ac all over 2a. So notice our first quadratic equation is not in standard form. So you can do either moving the 2 to the left side or moving the others to the right side. I always prefer to have my leading coefficient be positive. So I'm going to write this as 0 equals x squared minus 5x plus 2. So we added x squared to both sides and subtracted 5x from both sides. So now looking here, we have a is 1, the coefficient of x squared, b is negative 5, and c is 2. So using our quadratic formula, we would have x equals negative 5 plus or minus the square root of the quantity. We have negative 5 squared minus 4 times 1 times 2 all over the quantity of 2a, which is 2 times 1. So we end up with 5 plus or minus, and then underneath our radical, negative 5 squared is 25, minus 4 times 1 times 2 minus 8 over 2, a little longer radical than we needed, and we end up with 5 plus or minus the square root of 17 over 2. And since 17, there is not a perfect square, we can't take the square root of that, and there are no factors of 17 that are perfect squares, so we can leave our answer like that. Looking at our next problem, again, we want to put it in the standard form to start. So I will subtract 12x and add 13. So we have a is 3, b is negative 12, and c is 13. So we have x equals, again, minus or negative 12 plus or minus the square root. We have negative 12 squared minus 4 times 3 times 13, all over 2 times 3. So that leaves us with minus a minus, that's a positive 12, plus or minus the square root. Negative 12 squared is 144, minus 4 times 3 is 12, times 13, that's 156, all divided by 6. So notice here, we're subtracting a larger number from a smaller number. We know that's going to leave us with a negative. So that's negative 12 over 6. So we're going to have an imaginary solution. So the square root of negative 12 can be written as the square root of negative 1 times the square root of 4 times the square root of 3. So we have I times 2 times root 3, or 2i root 3. So we're going to substitute 2i root 3 for our square root of negative 12. And then what I'm going to do is I see that I have a common factor of 2. So I'm going to factor a 2 out of the 2 terms in the numerator. So that leaves us with 6 plus or minus 1i root 3 over 6. 2 divides into 2 once, into 6 3 times. So our final answer would be 6 plus or minus I root 3 over 3. Always critical that when we are dividing, that we have a sum or difference here in the numerator that we're factoring out, and not just doing these 2 terms, but this as well. Okay, let's look at a problem where we're looking at what we call the discriminant. Okay, so the discriminant is the radicand, which is b squared minus 4ac. And so that actually tells us about the number of solutions and the type of solutions we have. So I'll put this right here in the middle. If b squared minus 4ac is a negative number, then we have 2 imaginary solutions. If b squared minus 4ac is equal to 0, then we have 1 real solution. And if b squared minus 4ac is a positive number, we have 2 real solutions. And here they can either be rational or irrational, and you'll see some examples of both. Okay, so here, A is the coefficient of x squared, which is 1, B is 1, and C is 4. So B squared minus 4 times A times C. We have 1 minus 16, that's negative 15. Because that is less than 0, we have 2 imaginary or complex solutions. Okay, moving over to number 2, A is 2, B is negative 1, C is negative 5. So again, B squared, so that's negative 1 squared minus 4 times 2 times negative 5. So that'll be 1. 4 times 2 is 8, times 5 is 40, minus a minus becomes plus, so 41. Okay, so we know there are 2 real, and because 41 is not a perfect square, then they are 2 real and irrational solutions. Okay, down here to number 3, A is 3, B is 4, C is negative 4. So we have B squared minus 4 times A times C. So 16, 4 times 3 is 12, times 4 is 48, minus a minus, that becomes plus. So 64. Well, that's a positive number, so we know we have 2 real. And because 64 is a perfect square, we know they will also be rational. And our last one here, A is 1, B is negative 4, C is 4. So we have B squared minus 4 times A times C. So 16 minus 16 are 0. So in our quadratic formula, the B squared minus 4AC would be 0. You're only left with the negative B over 2A. And this means we only have 1 real, and it is rational solution. And let's look at one final problem. Here what we're given is a solution, and we're asked to write the quadratic formula, or quadratic equation rather, that fits that. So remember, we have negative b plus or minus the square root, b squared minus 4ac over 2a. So looking here, we know that negative b has to equal negative 9, so we know b is 9. The denominator, 2a equals 4a equals 2. And then lastly, our radicand, or discriminant in this case, b squared minus 4ac has to equal 137. Well, we already know b is 9. We already know a is 2. So notice really what we're left with is this linear equation. So we have 81 minus 8c equals 137. We'll subtract 81. Negative 8c equals 56. And so c is negative 7. So the quadratic equation, a, b, and c, would be 2x squared plus 9x minus 7 equals 0. And that would yield that from that solution. Hope that helps, and we'll see you soon.